Yesterday, I remember talking about EnbBoost, which is a program that also comes along with EnB. So you got to kind of excuse my voice. I just woke up, and man, it's definitely gravel for a while. But remember, I was talking about part of the problems with 32-bit programs was the amount of virtual memory each one could have. Uh, for some for some reason, when Bethesda compiled Fallout 3 and Vegas, for some odd reason they didn't compile it with the extended memory flag set, and I believe that's a compiler option. So right out of the box, the program could only access or could only have at a maximum of 2 gigabytes of virtual memory. And in that virtual memory, I believe that probably anything. I'm going to assume at this point it's also loaded libraries, but I'm I wouldn't think it's the full library. I would think it's any references or links to the library, but it includes anything the game loads, scripts, anything allocated like tables, lists, variables that's used to keep track of different things. If it loads records into memory, like the plugins, the IFF plugins, when it loads those up, anything the game is going to have to put into memory takes a chunk out of that 2 gigabyte virtual memory space. And that's because, it was a 32-bit program. You can extend that. That's what those, I think they're called not extenders, but patchers. And it really only sets 1 byte. And if you ever look at an executable, you can actually see the header. There's a little marker for it. And it's just what it is. It's a control structure. So when Windows loads the program, it can kind of make sure that it runs in the proper environment. Because with those headers, you can create what they call portable code, where the header defines the environment in which the code can be run, and if you have a system that can do that, then it will make sure that it runs properly. By patching it, you can actually access 4 gigabytes. Well, EnbBoost kept it down to 2, created 2 gigabyte blocks. So what I wanted to show you is EnB at work, or the EnbBoost at work. Now this was a while back. This was TTW, and this was the first iteration of the program I'm using now. You can see it looks a little bit different. It still had tabs and all those kind of things. The messages were, it was really separate windows. You had a separate windows for your tabs, separate window for your plugins and install order, and a separate window for your messages. Here I kind of combine them in one giant application, but you can break those windows out. I just simply relink the control. Okay, but let me let me try to stay focused. I haven't had coffee this morning, so let me try to stay focused on what I'm doing. All right, so you have two graphs. One of the graphs where EnbBoost was working, one of the graphs where EnbBoost was not. And what you want to look at is this green graph here. So basically what I did, I have a program. It's a standalone program, and it's basically a command line program. And what it does is it captures data when a particular program is running. It captures virtual memory data. I think it captures disk cache requests, things like that. Everything up here it captures, and it'll capture it per processor if you have a multi-processor system. And once it captures it, the previous application, the very first iteration, which is what you see here, these are screenshots from that. The very first iteration would allow me to load a text file that had this captured data, and then it would graph whatever was in that text file. So I could literally have multiple text files, which are basically multiple performance dumps, and then I could load these performance dumps and take a look and see exactly what might be causing the problem and things like that. So it looks a little bit like Performance Monitor, but it's more for a specific program. In this case, it's for Fallout New Vegas. So if you look over here at the green bar, you see where it says total memory usage is 2.42 gigabytes. And then over here, you see memory usage peak. This is a peak, and it was a peak over here at 3.35. Now, this is the instance over here where EnbBoost was not working. And this is for Fallout Vegas. So a while back, there was a problem with a combination of settings. And I used the combination of settings as it said out of the box, but it would crash on me. So once I'd play for a couple minutes, it would crash. Play for a couple minutes, it would crash. Play for a couple minutes, it would crash. So what was happening was all these references and all this data and these scripts and all these things are being loaded into memory. Now this included loading the graphic images or shadowing the graphic images that would normally be loaded into VRAM, which is your graphic, your GPU, your graphic card's RAM. It shadowed the very same image in your virtual memory for your program, in your RAM. So it was stored in two places, and that was the fault of DXD9, or the yeah, it was the fault of DXD9. God, I can't even think this morning. I need more coffee. That's the program that controls the, allows you to draw or render, as a better term, graphics into a viewport or into a window or anything that has like a bitmap. So you can see where it was 3.35 because I kept getting a crash. I'm like, wait a minute now. I've got the settings set up in EnbBoost exactly like he said, but I'm crashing. So what's the problem? So I actually captured some metric data as New Vegas was running, and you can see as I approached, it wasn't. I think it was Nipton. It was that area that was almost right before, I believe, the ranger station, or it might have been the ranger station in New Vegas. And you could see where RAM usage started to really go up. So it's loading new references, and then it would crash. This was the end of the sample. So this is when EnbBoost, I couldn't get it to work properly. So we were trying to figure out what it was. And every time this was the same thing. Once it kept going up, it got up near the 4 gigabyte mark, and the actual game would crash. Over here, you can see where Fallout Vegas and EnbBoost, I got it working properly. And you notice that the total memory usage is about 2.5 gigabytes. This is what EnB does. Notice how it leveled out. So what was happening was once a certain amount of graphics got close to or around a limit, so let's say he set it at 2 gigabytes, he would know, he would keep a reference of what the texture names were and what was stored in each 2 gigabyte memory chunk. And then he would have another, he would launch another EnbBoost and another EnbBoost. I believe that's what it did, depending on how many, because I think each EnbBoost was 32-bit, so it would launch multiple copies of itself, each dedicating itself to a certain set of certain set of textures, and then it would bank switch that out. So you can see how it's a steady bar. So once it got to whatever the EnbBoost limit is, every time new graphics loaded, it would fire off another copy of itself and make sure that whatever the virtual RAM usage for Fallout New Vegas didn't exceed 2 gigabytes, I believe is what he had said. Here you can see where it wasn't working, it just kept shadowing the textures into the virtual memory allocated to Fallout 3, because that was D3D9's fault. I don't know why Windows would do that. Other than the fact it was done for, they never really considered the fact that graphics would get that the requirements for graphics or the load for graphics wouldn't be that much, and therefore they're thinking, well, we'll just shadow it in RAM, and therefore anytime we need it, we can literally copy it from RAM straight into graphics memory, and that will give us a performance boost, an FPS performance boost, over having to load it back off of an external storage drive, which I don't think at that time SSDs existed, so I think it was all like just hard drives. And you were talking probably what, 5400, 7200 RPM drives. But that's the difference. So EnbBoost, once it got 2 GB or whatever, 4 GB, or I think it was 2 GB, it would create a copy of itself. And then once that one got full, it fired off, I believe, another copy of EnbBoost. And that's why you would have multiple EnbBoost copies running. But here you can see that it capped the virtual usage. It captured and capped the virtual usage for Fallout 3. I mean Fallout New Vegas at about 2.5 GB, and it never went higher than that. Whereas without that EnbBoost, it kept going up higher and higher. Now there's a application which I think is the memory fix, which I'm pretty sure is going to be for Vegas too, because if it's for Fallout 3, it's going to be for Vegas, and it will keep from shadowing. It'll keep from using up your game's virtual memory space, which is needed for scripts and other types of data. It'll keep from using it up just to load shadowed copies of textures. I don't know the name of it. I'll look at it here in a little bit and see, because I do want to mod Vegas, and I do want to get kind of like a base game going. But I've got like I kind of want to build the ability to recreate a complete game many different ways. I've got some of the code in here, so it'll take me longer to do it, I guess is what I'm saying, because I'm going to have to do it step by step, and then I'm going to have to translate what I'm doing into code and then test that out each iteration to make sure that it works. But yeah, that's all in a future project. But yeah, that was the difference. That's what EnbBoost did. So thought that might help, and good luck and have fun playing your game.